Okay, hello everyone. In this video, we are going to discuss Compton effect, its concept and mathematical derivation. Okay, so let's start. Consider a electron is at rest in the xy plane at the origin. So this is an electron which is at rest. So obviously rest mass energy of this electron will be m naught c square. Here m naught is nothing but your rest mass of electron, that is your 9.1 into 10 to the minus 31 kg. Okay, now consider a photon incident on this electron having energy h mu or momentum h mu by c. Momentum, how it will be h mu by c, here I am going to explain. We know according to de Broglie, matter wave having the wavelength is your h by p. P is the momentum, h is the Planck constant. We know this one. Okay, that implies momentum p will be equal to h by lambda. Okay, for a particular light wave, speed of the light is your c equal to lambda by time period, or we can write lambda into mu, or lambda is equal to c by mu, that we know. If we are going to put this value over here, then we can found momentum is your h mu by c. Okay, so when incident photon incidents on a rest electron having energy h mu and momentum h mu by c, this incident photon after collision with this electron scattered along this direction. The incident photon scattered along this direction with an angle theta with x-axis. So after scattering this incident photon, let its energy changes from h mu to h mu dash. So obviously momentum will be h mu dash by c. So obviously here energy will be reduced, because when it will interact, this incident photon will be interact with this electron, some of the energy will be gained by this electron. So when this rest electron will be gained some energy from this incident photon, let this electron moved or recoiled along this direction. So this is the recoil electron direction. Let the angle phi with x-axis. So here we consider the recoiled electron recoiled or moved with an angle phi with x-axis. Okay, after this, let when it is recoiled, let its velocity is your v. So hence energy or the so called relativistic energy of this electron will be mc square. Initially the rest mass energy of this electron was m naught c square, here mc square, and here m is your, here this m is your relativistic mass, and we know that the relativistic mass m equal to gamma into m naught, and here gamma is nothing but 1 by 1 minus v square by c square root over. So here v is your this velocity v, and c is your speed of light that we know. So relativistic energy of this recoiled electron, let it is mc square. Corresponding momentum will be mv. Okay, so this space we have been considered as before collision space. This is your after collision space. So here you can observe that after collision of this incident photon, this is your scattered photon, the energy reduced. If energy reduced, that means this frequency, that means mu dash also reduced. That means mu dash is less than that of the mu. ये तुम्हारा फाइनल फ्रीक्वेंसी किसका, स्कैटर्ड फोटोन का. दिस इज योर इंसिडेंट फोटोन इनिशियल, और इंसिडेंट फोटोन का ये फ्रीक्वेंसी है. तो आफ्टर स्कैटर्ड दिस म्यू डैश obviously less than that of the initial mu, hence energy h mu dash will be less than that of the h mu. So if this mu dash is less than that of the mu, so we know that c velocity of light, sorry, mu dash or mu frequency and wavelength, they are related like this. Okay, so if mu dash is less than mu, so therefore lambda dash will be greater than that of the lambda. That means the wavelength of this scattered photon, this wavelength, this is the wavelength of incident photon, this is the wavelength of scattered photon. For the scattered photon wavelength, suppose we have been considered lambda, and for the incident suppose lambda dash, for the incident suppose lambda. So here lambda dash will be that greater than that of the lambda. Okay, so how much changed, how much your wavelength changed here after scattering of this photon, change of wavelength will be lambda dash minus lambda, or we can say, change in frequency will be mu minus mu dash, because this is larger, this is smaller. Or if we have this data, suppose lambda dash minus lambda we found, so suppose this value is your del lambda, suppose I consider that del lambda is your lambda dash minus lambda, hence del mu change in frequency will be how much, we are going to consider this formula, that is your C by del lambda. Okay, so here according to the definition of the Compton effect, the phenomenon of change in wavelength or frequency, here mu dash I written, change in frequency of scattered photon or X-ray or gamma ray from the electron is called as the Compton effect. So when a incident photon or X-ray or gamma ray will be incident on a rest electron and scattered, what will be the change in wavelength or frequency of this scattered photon, that is called as your Compton effect. Okay, so here easily we can get one data that see, this is the scattered energy of the scattered photon, this is the incident energy of the incident photon. So here h mu dash is less than that of the h mu. Why? Sum of the energy gained by this electron, जितना एनर्जी ये इलेक्ट्रॉन लेके इस दिशा से वो रिकॉयल हो गया, उतना एनर्जी रिड्यूस हुआ, उसका मतलब ये है h mu minus h mu dash, change in energy is nothing but gain by this electron. Okay, okay, so this is all about the discussion of this figure. Now using this figure we are going to derive the mathematical derivation of del lambda, that is your lambda dash minus lambda will be how much. Okay, now we are going to go for the mathematical derivation. Okay, actually this Compton effect first experimentally has been confirmed by Arthur H. Compton in 1923, and this effect is the evidence, or this effect provides the evidence about the particle nature of the light, because here we considered the light have some momentum. So we know that if we have a particle or a matter, only matter have the momentum, but light or wave could not have the momentum. But as we are considering this light or incident photon have the momentum, so this effect provides the evidence about the particle nature of the light, which supports the concept of the photon having momentum. Okay, and here I'm going to tell to you that the experimental verification what observed by Arthur H. Compton, that we are going to discuss in our separate video, but in this particular video we are going to discuss the mathematical derivation of the Compton effect. And here I written once again the definition, already we have been discussed, that the phenomenon of change in wavelength, that is your lambda dash minus lambda, or frequency mu minus mu dash of scattered photon or X-ray or gamma ray which is scattered from an electron, called as the Compton effect. Now we are going to go for the mathematical derivation. In short, I have been written what already we have been discussed in this figure. Here considered an incident photon, this is your incident photon or radiation having energy h mu, momentum h mu by c, incident on an electron which is at rest after collision. Let the incident photon scattered with an angle theta and electron recoiled with an angle phi. This is the scattered photon, this is your electron photon, already we have been discussed, which is represented in figure 1, right? Now the detailed dynamics of incident and scattered radiation and recoiled electron in before and after collision is shown in the figure. So here before and after collision entire dynamics is shown in the figure 1. So here you can see after scattered this photon, photon moved along this direction and the electron moved along this direction uh, with an angle theta, scattered photon with an angle theta with x-axis, and electron with an angle phi with x-axis. If it is so, then this momentum, that is your h uh, mu dash by c, will be is your vector quantity. We know that always momentum is a vector quantity. If it is so, then it will be resolved by two components. Along x-axis it will be h mu dash by c cos theta. Along y-axis it will be h mu dash by c sin theta. Likewise, along this way the velocity is v, and if this is your angle phi, this will be angle phi, and this momentum, the momentum of electron, will be resolved by two component. Along horizontal component, that is your mv cos phi, and vertical component or along y-axis, this is your along negative y-axis, that is your mv sin phi. I'm going to show you the animation, you can easily understand, and here you can watch. So this is the Compton effect what we have been discussed. So if it is so, uh, the momentum of scattered photon have two components. Along x-axis uh, will be your h mu dash by c cos theta, and along y-axis, positive y-axis, will be h mu dash by c sin theta. Likewise, for electron, when it is recoiled along this direction with an angle phi, so this angle phi means this angle also will be phi, and its horizontal component, momentum horizontal component, will be mv cos phi, and vertical component, that means along negative y-axis direction, is your mv sin phi. Okay, now we are going to equivalent the before collision energy and after collision energy of the system. Before collision total momentum, and after collision total momentum of the system, because we know that before and after collision the energy has to be conserved and the momentum also has to be conserved. So by considering this conservation laws, we are going to derive the mathematical derivation of the Compton effect. Okay, so here we found this is your x component of momentum of scattered photon, this is your y component, this is your x component electron momentum, and this is your y component of electron momentum. First we are going to consider the law of conservation of energy. That means energy of system before collision will be equal to energy of the system after collision. So before collision, what was the energy? Before collision, in the collision space, you can see before collision the energy of the incident photon was h mu, and energy of the rest electron is your m naught c0. So before collision the total energy will be h mu plus m naught c square, and after collision the energy of the scattered photon is your h mu dash, and recoiled electron energy is your m c square. Here m uh, here, so h mu dash plus m c square. So here m naught is your rest mass energy, and you just write, I will write in your note, m is your relativistic mass of the electron, relativistic mass of electron. Okay, now consider law of conservation of momentum along x-axis. Law of conservation of momentum along x-axis before and after collision. So before collision along x-axis, what are the momentums? Here for the incident photon, momentum was h mu by c. As electron is at rest, the momentum before collision will be 0. So before collision the total momentum is your h mu by c, and momentum for the electron is 0. After, along x-axis I am telling, after collision along x-axis the momentum of a photon will we get, that is your h mu by c cos theta, and momentum of electron along x-axis we found how much, mv cos phi. Here I written h mu dash cos theta, that is your momentum of scattered photon, and this is your momentum of recoiled electron along x-axis. So here I just written simply solve this equation, and we found here, if I am going to add, c will be multiplied with this one, and then h mu dash cos theta. If I will take this side, then it will be minus h mu dash cos theta. Okay, so let this is your equation number 1. Now consider law of conservation of momentum along y axis. Before collision along y axis there was no momentum, because photon incident only along x axis, there was no y component. So and electron is at rest, so before collision there was no momentum we can found. So for the photon it was zero. For the electron also it was zero. After collision along y axis, here for the scattered photon is h mu dash by c sin theta, and here momentum of electron is mv sin phi. But here the two momentums are opposite with each other. Here along y positive y axis, for electron along negative y axis. So net momentum along uh, y axis will be h mu dash by c sin theta minus mv sin phi. Here minus sign is nothing but both are opposite with each other, right? So from this equation we can found mvc sin phi in equal to h mu dash sin theta, right? Okay, let this is your equation number 2. Sorry, this is your equation number 3. Let this is your equation number 3, right? Now squaring equation number 2 and 3 and then add together. Here this is your equation number 2 and this is your equation number 3. Just add them and we get square. First square them, then add. If I am going to square, this will be m square v square c square cos square phi, and this will be m square v square c square sin square phi. And this side if I will do if I will square, then it will be h mu minus h mu dash cos theta square, and here this will be h mu dash sin theta square. Okay, here you can see from these two terms I can take common m square v square c square. So in bracket it will be cos square phi plus sin square phi. Here you can see I just consider the square of these two terms, that is your h square mu square. Okay, h square mu square, I'm going to write here h square mu square plus h square mu square cos square theta minus 2 this and this, that means h square mu dash cos theta, and this one is your h square, here h square mu dash square sin square theta. So here what I done, this term I written as such. Here this term minus 2 h square mu dash cos theta, here I written. From this term and this term I taken common as h square mu dash square. Here I uh, here this will be h square mu dash square. Okay, so if I will take common h square mu dash square, we can get cos square theta plus sin square theta. Here I not written this step, no need to write this one. So we got this one. So by solving here, cos square phi sin square phi cos square theta sin square theta will be 1. So this will be m square v square c square will be equal to h square mu dash square minus mu 2 mu dash cos theta. Let this is your equation number 4. From equation number 1, here from this equation what we can write, from this equation here you can see, here from equation number 1 what we written that m c square, here m c square will be equal to this term plus this term minus this term. Same thing it has been written that h mu minus plus m naught c square plus m naught c square minus h mu dash. So that implies mc square will be equal to, here I taken common h from these two terms, h into mu dash, mu minus mu dash m naught c square, right? Now we are going to square the above equation. If I will do the square of this equation, what we can found, m square c to the 4. Okay, and squaring this one, it will be h square mu minus mu dash whole square. Okay, and this one, see, if I will square right hand side, that means we have to do like this, squaring of this one. This one means this will be A and B. So A square means this one, B square means m square c to the 4, 2 into this term and this term I have been written over here. So let this is your equation number 5. Okay. Now subtract equation number 4 from 5. 4 from 5 means this one. This we have to subtract this 4 from 5. So we can get that, what we can get here, m square c to the 4 minus this one m square mu square c square I written over here, and I written these three terms, first, second, third, minus this term, right? Then here here m square c square I can take common from these two terms. We can found c m square c square into c square minus mu square, right? Here m naught square c to the 4 I have been written over here. Okay. Then this term 2h mu minus mu dash m naught c square, here I written. Okay. Okay. And then here you can see, if I am going to consider this term, that means this is your what, h square, this is mu minus mu dash whole square, it will be mu square plus mu dash square minus 2 mu dash. Okay. So if I am going to solve it, this will be h square mu square plus h square mu dash square minus 2h mu dash. Then here another three terms are what, minus h square mu square, then minus h square mu dash square plus 2h mu dash cos theta, right? So here h square mu dash square, h square mu dash square got cancelled. Okay. H square mu square minus h square mu square got cancelled. We got these two terms. So from these two terms, if I will take common 2h mu dash, then we can found 1 minus cos theta. So if I am going to take minus 2h square, so here I mistakenly written that 2h, this is 2h square because it is h square. So here h square means h square. Okay. So if I will take common 2h square mu dash, it will be 1 minus cos theta, right? Now, okay. Now here c square, see m square c square into c square minus mu square, value is your m square c to the 4. How it is? See, we know that this m is nothing but your relativistic mass, is equal to gamma into m. Gamma value is your 1 by 1 minus v square by c square into m naught. Okay. So you just multiply, first square both the side. If I'll do the square, then it will be m square, m naught square, and root over is going to be cancelled out. So after that I multiplied with this term with this one, so it will be 1 minus v square by c square m square equal to m naught square. You just solve it, we can found m square c square into c square minus mu square equal to m naught square c to the 4. So instead of this one, I substituted m naught square c4 is equal to m naught means m0 square c to the 4 plus 2h mu minus mu dash m naught square, here this term as such I have been written. So here m naught square c to the 4, m naught square c to the 4 got cancelled, and we found this one. If I will take this term this side, left hand side, it will be minus and another minus is there, so plus 2h mu minus mu dash m naught c square will be equal to this much, 2h square mu dash into 1 minus cos theta, right? Now I am going to divide mu dash with each term, left hand side and right hand side. So if I am going to divide mu dash both the side, here here you can see 1h, and here h2 got cancelled. Then I am going to divide mu dash both the side. So here mu dash divided with left hand side, we found mu minus mu dash by mu dash, and this m naught c square I taken to the right hand side. So in the right hand side, we have only h. If I divide mu dash, got cancelled, so h by m naught c square. M naught c square I taken from this side to this side into 1 minus cos theta, right? So if it is so, if it is like this, then if I will divide mu by mu dash, we found 1 by mu dash. Mu dash by mu dash, we can found 1 by mu equal to h by m naught c square into cos theta. Then I multiplied c both the side. So here c by mu dash minus c by mu is equal to, if I multiply c with the right hand side, so c, 1 c got cancelled, 1 by h, sorry 1 by, sorry h by m naught c into 1 minus cos theta. Finally we found, and we know that uh, c by mu in general is the lambda. So c by mu dash will be written as lambda dash, and this is your lambda. So this is the wavelength of scattered photon, and this is your wavelength of incident photon. So here lambda dash minus lambda is written as del lambda, which is nothing but called as the change in wavelength, and also this change in wavelength is called Compton shift, and we found h by m naught c into 1 minus cos theta. Finally we found the change in wavelength expression is this one. I suggest that you just remember, it is very very important, this expression. Directly you can get the questions in your exam, that you have to use this expression or formula, you can say. So in Compton effect, this expression is most important. I suggest that just remember it. Okay, and this equation number 6 also can be written as, here you can see, we know that c by lambda, c by mu equal to lambda. So c by lambda will be mu, c by del lambda is nothing but del mu, right? So here instead of del lambda we can write c by mu, or del mu is nothing but c by del lambda. So with the help of this equation number 6, we can calculate the del lambda. Then we can easily found del mu, which will be c by del lambda. Okay, okay, and here h is called as your Planck constant, m naught is your rest mass of electron, that is your 9.1 into 10 to the minus 31 kg. C is the speed of the light. All are constant, represented as lambda 0, called Compton wavelength. Also you have to remember this expression of the Compton wavelength. Directly you can found 1 mark question in your exam. Okay, now we are going to consider 3 cases here. If we are going to consider theta equal to 0, theta equal to 0 means scattered angle is 0. That means incident photon moved along the same direction uh, in which it has been incidented. So along this direction it has been incidence on this particular electron, and along the same direction it has been scattered. So theta is 0. If it is so, then del lambda will be 0. There is no change of wavelength we can found. uh, we are going to found if theta equal to 0. If theta equal to 90 degree, so cos 90, if we are going to consider this value is 0, so we can found h del lambda, that means change in wavelength of the scattered photon, will be equal to a constant value, that is your h by m naught c. If I will substitute all the values, Planck constant value, and this is your mass rest mass of the electron, this is the speed of the light, we can found a constant value, that is your 0.024 angstrom. I suggest also you remember this one, because this will be help you to solve the problem easily. Okay, h by m naught c is your value, is this one. Then if 180 means when the photon is going to be scattered just opposite to the incident. So along this way it has been incidence on this electron, along this exactly opposite, if it will scattered, then what will the change in wavelength we can found 2h by m naught c, just double as compared with theta equal to 90 degree. So these three cases also you have to remember. Okay, so if this question asked 6 to 7 mark in your exam, you have to draw this figure compulsory, you have to draw perfectly this figure. How much I have been written, you just write that much, no need to write extra. Okay, okay, I will upload this note, and I'll give the link in the description. You can download this note and prepare yourself for your exam. Okay, okay, Here, there are the three major applications of the Compton effect. That is your medical imaging. Compton effect used for medical imaging, material analysis, and astrophysics. Medical imaging means X-ray interaction with matter is essential for the development of the diagnostic technique such as X-ray imaging or computed tomography. So, suppose human body is there. Uh, X-ray interacted some part of the human body to know the defect. So if it will interact exactly the defect, then we can extract the exact information about that defect. So uh, for the diagnostic technique, this medical imaging diagnostic technique, this effect, the Compton effect, also useful. Likewise, material analysis means a unknown material, its structure can be found by using Compton scattering. Astrophysics, in astrophysics, Compton effect also essential. So here three major applications I have been written. Sometimes in your exam you can found just write the two applications or three applications about Compton effect. You have to write any two of them. Okay, now we are going to go for a important question based upon this Compton effect. Very important question. If you do this question or practice this question, you can solve any question which is based upon the Compton effect, right? The question was here, the question what it has been given here, question given that the incident radiation energy, how much, 1.03 mega electron volt scattered from an electron which is at rest by an angle 90 degree. Calculate the velocity of recoil electron and then find out the energy of the scattered radiation. So here the two questions we are going to solve. So in question what it has been given, the incident photon, initially its energy was 0.13 mega electron volt. Initial h mu value given as 1.03. It is scattered along this direction, 90 degree, 90 degree. Okay, then scattered through the electron, rest electron, but along this direction, along positive direction, positive y-axis direction, means with an angle 90 degree. So what will the velocity of recoil electron and energy of the scattered radiation? First we are going to calculate this one. We know the change in wavelength. How much we found the expression? The expression was del lambda or lambda dash minus lambda of the scattered photon is your h by m naught c into 1 minus cos theta. Here theta given 90 degree. So del lambda will be how much? Here if I will put theta equal to 90 degree, so this cos theta will be 0. So we found del lambda is your h by m naught c. This value is your 0.024 angstrom. 024 angstrom. Here I written. I suggest to all of you that you just remember this one. Okay. Otherwise in the exam you have to you are going to give the time to calculate. Just remember this one. So angstrom means 10 to the minus 10 meter. Hence change in frequency will be how much? C by delta lambda. So change in frequency, if this will be a change in lambda, change in frequency will be C by delta lambda. Here C is your speed of the light. You just calculate. You can found 1.2 into 10 to the 20 hertz. Here most important, this line is most important. Here this is a change in energy. So change in frequency. Change in frequency we found this much hertz. So change in energy will be how much? Because we know that E equal to Planck constant into mu. So here change in frequency we found this much. So change in energy delta E will be h into delta mu. How much we found? If I am going to calculate this value, h value is your 6 point, this is the Planck constant. I substituted delta mu, change of frequency value I have been substituted, and I found this value. This value is your change of energy. Change of energy. Okay, change in energy. Right. So here change in energy means what? Change in energy means final energy minus initial energy, right? That means your h mu dash minus h mu. In the figure you can see the final energy after scattered. What is the energy? H mu dash. At the time of incident, energy was h mu. So change in energy is nothing but, see, I written just reversely, because we know that after scattered its energy is going to be reduced. So h mu is greater. So h mu minus h mu dash is the change in energy. That means E minus initial minus final is the change in energy. Okay. So if it is so, this is nothing but called as the delta E. So this change in energy is nothing but initially कितना था minus final. This energy will be gained by, so this energy, this much energy, this energy, change in energy will be gained by the recoiled electron. Got it? This change in energy means initial energy minus final energy. That means this is the loss of energy by the after scattering. So this is energy lost by the scattered photon. So lost energy gained by the recoiled electron. So this much energy, this change in energy is nothing but energy gained by the recoiled electron. So recoiled electron gained energy this much, and it this much energy utilized as kinetic energy of the recoiled electron. This change, again I am telling, this change in energy is nothing but loosed by this delta E energy loosed by scattered photon, gained by recoil electron, and utilized as kinetic energy of the recoiled electron. Got it? Now, but we know relativistic kinetic energy of electron is nothing but mc square minus m naught c square, which will be equal to how much? This one 0.496 mega electron volt. This is your relativistic mass, is related with rest mass as gamma into rest mass. Gamma is nothing but 1 by 1 minus v square by c square root over. Okay. Now, consider this equation. mc square will be equal to how much? 0.496 plus m naught c square, and here this will be equal to 0.496 plus, see, m naught, or this is your rest mass of the electron, 9.1 10 to the minus 31 kg. This is the speed of the light. So this value is a constant. If you are going to calculate, you can find this value 0.0511 value. So mc square we found 1.007 mega electron volt. If I will convert it from mega electron volt to joule, then it will be 1.611 into 10 to the minus 31 joule, because we know 1 mega electron volt is your 10 to the 6 electron volt. Again, 1 electron volt is your 1.6 into 10 to the minus 19 joule. So we found this one, this much value. mc square value is this much. So m will be c square has been divided, c का value यहाँ पे डाल दिया मैंने, and we found this much. Okay, m, this is nothing but your relativistic mass value is this one. I substituted over here m naught by 1 minus v square by c square equal to this one, and I this value I taken this side, this value I taken this side, and taken square both this side. If I do the square both this side, the root over is going to be cancelled out, and after solving this one, we can found velocity of the electron will be 0.856 c. Here c is your speed of the light. Finally we found this much value, velocity of light. This is the answer of the first bit. Now, what is the energy of the scattered photon? Scattered photon means initially energy of the photon was 1.03. It loosed, the photon loosed energy how much? This much value. Here change in energy means loosed. That much energy loosed by the scattered photon, gained by the recoil electron. How much? 0.496. If it is so, then the rest energy will be how much? Remaining energy will be how much? 1.03 minus 0.496 equal to 0.534 mega electron volt is the energy is the remaining energy of the scattered photon. Got it? So this is the this one is the one of the important question belongs to Compton effect. I suggest that you just go through this video about the Compton effect and its mathematical derivation, practice it for your exam, and then you go through carefully this question for your exam point of view. Okay, thank you so much. If you like this video, please be subscribe and share with your friends. And in our next class we are going to discuss evaluation of direction of recoil electron. 5 we are going to evaluate. Then next class we are going to discuss next class we are going to discuss this one. Then we are going to discuss experimental confirmation of Compton's effect. Okay, so thank you so much for watching this video. Thank you.